Okay, today we're going to be looking at section 5.2, trigonometric functions of real numbers. And what we're going to be doing today is actually introducing the 6 trig functions that you're going to be working with over the next couple of chapters. Those 6 trig functions are sine, cosine, and tangent, which are the 3 functions that you've hopefully already heard of. Then their reciprocals, the reciprocal of sine being cosecant, the reciprocal of cosine being secant, and the reciprocal of tangent being cotangent. And we are going to start applying these trig functions to the unit circle, and I'm going to start showing you how they relate to the unit circle. The sine of an angle, all that is the y value. It's y value on the unit circle. So for example, the sine of 90 degrees is going to be the y value at 90 degrees, which is 1. The cosine of 90 degrees, as you can see, the cosine of an angle is its x value. So while the sine, the y value is 1, the cosine would be 0. Then the tangent of 90 degrees, or the tangent of an angle, is the y value divided by the x value. So the tangent of 90 degrees would be 1 divided by 0. And we all know that 1 divided by 0 is undefined, so there is no tangent of 90 degrees. The cosecant of 90 degrees is basically the reciprocal of the sine. So what is the reciprocal of 1? The reciprocal of 1 is 1 over 1. So the cosecant of 90 degrees is 1. The secant of 90 degrees, or the secant of an angle, is the reciprocal of the x value. In this case, the x value is 0. So the reciprocal of 0 over 1 is 1 over 0, which again is undefined. So there is no secant of 90 degrees. There's no tangent of 90 degrees or secant because you get 0 in your denominator. Then lastly, the cotangent of 90 degrees is going to be x over y, or the reciprocal of the tangent of 90 degrees. Do you see that the tangent of 90 degrees is 1 over 0? So the reciprocal of that is going to be 0 over 1, which is, in fact, 0. So the cotangent of 90 degrees is 0. Okay, so what we're going to do is we're going to do a couple of examples of finding the 6 trig functions of certain angles. So, for example, to find the 6 trig functions of t equals pi over 3, first we need to locate that on the unit circle. Pi over 3 is 1/3 of pi. And if you'll remember, pi is at 180 degrees, pi over 2 is at 90 degrees, and 3 pi over 2 is at 270 degrees. So this is 1/2 pi is at pi over 2. So 1/3 pi is going to be somewhere in quadrant 1. We don't know where, but we can go ahead and draw our little reference triangle. We need to figure out what pi over 3 is in degrees. So pi over 3 radians. We divide by pi radians. We multiply by 180 degrees. And you see in dividing, we cancel pi, and pi over 3 comes to be 60 degrees. So that means this reference angle is a 60-degree angle. And because that's a 60-degree angle, we can refer to our handy little reference or special triangles over here. And do you see that the angle across from the 60-degree angle is root 3 over 2? So this would be root 3 over 2 here. And the angle across, this would be a 30-degree angle. So the angle across from the 30-degree angle would be 1/2. So now that we have found the 2 sides of the triangle, we know that this ordered pair here is going to be 1/2 comma root 3 over 2. So the sine of t, remember the sine is the y value. So do you see that the y value here is root 3 over 2? The cosine is the x value. So the cosine is going to be 1/2. The tangent is sine over cosine, or y over x. So let's figure out what that is. That's going to be root 3 over 2 divided by 1/2. So we say root 3 over 2 times 2 over 1. 2's cancel, so the tangent of t is the root 3 over 2. Now we need to find the reciprocal trig functions. Cosecant of t is just the reciprocal of sine t, so that is going to be 2 over root 3. But we all know we can't leave a radical in our denominator, so we're going to have to rationalize this. And so we end up with 2 root 3 over 3 for our cosecant. Secant is the reciprocal of cosine, real easy, that's just 2 over 1, which is 2. And cotangent is the reciprocal of tangent. Tangent is root 3, so cotangent is going to be 1 over root 3, which is root 3 over 3, rationalized. So those are the 6 trig functions of pi over 3. Now let's try a simpler one. Let's find, well, let's not do pi over 2 because pi over 2 is 90 degrees. Let's do 3 pi over 2. Let's find the 6 trig functions of 3 pi over 2. First thing you need to do is locate that on the unit circle. 3 pi over 2 radians times pi radians over 180 degrees. Cancel radians, cancel pi, and you see that this is 270 degrees. So we know 3 pi over 2 is located here. So the sine of 3 pi over 2 is the y value, -1. Cosine is the x value, 0. Tangent is -1 over 0, y over x. So the tangent of 3 pi over 2 is undefined. Now we move to the reciprocal trig functions. The reciprocal, the cosecant of t, or the cosecant of 3 pi over 2 is going to be -1, or I'm sorry, the reciprocal of that, 1 over -1, which is -1. The reciprocal of secant is going to be 1 over 0, which is undefined. And the reciprocal of cotangent is going to be 0 over -1, which is 0. Let me check the time real quick. 7 minutes. Okay, so next thing we're going to look at now is the domains of the trig functions. And hopefully you saw a little glimpse of that in the few problems that we just worked. Some of these trig functions you'll see are undefined at certain angles, and we're going to be talking about why. We'll just kind of talk through how this happens. Sine, remember, is all of your x values. Sine is all of your y values. Is there any place that a y value itself on this unit circle is undefined? Do you see that here your y value is 0, starting at 0, your y value is 0. As you move along the unit circle, the y value increases to 1, and at 90 degrees your y value is 1. Then we go back down the unit circle this way, and your y value becomes 0 again, and then it goes down to -1 and back up to 1. So sine, the domain for y values on the unit circle is all real numbers. Because there's no time that the y value is undefined. The y value is always defined. Likewise, remember, cosine is your x values. As you move around the unit circle, you see that your x value starting at 0 goes to 1. It starts at 1. And as we move to 90 degrees, your x value goes down to 0. As you move to 180 degrees, the x value goes to -1. And as we move to 270, our x value goes back to 0. And as we move back up to 360 degrees, the x value goes back to 1. The x value is always defined no matter where we are on the unit circle. So for that reason, domain for cosine is all real numbers. But now let's think about tangent. Remember, tangent, first we're going to talk about tangent. Tangent is y over x. So let's think about tangent. looking at the fraction y over x, when is tangent undefined? Hopefully you've seen that tangent is undefined when x is equal to 0. Do you see when x is equal to 0, we have to look on our unit circle. Do you see at 0 degrees, x is 1. But as we move to 90 degrees, do you see that your x value is 0? Your x value is also 0 at 270 degrees. So tangent is undefined at pi over 2 and 3 pi over 2. You'll also notice that secant, of x, or let's write this, secant is 1 over x. So do you see that secant has the exact same problem that tangent has, where you have x in your denominator and x cannot be 0. So for that same reason, secant is undefined at pi over 2, where x is 0, and 3 pi over 2, where x is equal to 0. So the way we write this is that secant, tangent and secant, I'm going to erase this, their domain is all reals not equal to, not equal to pi over 2, which is 90 degrees, plus n pi for any integer n. What that means is basically the domain is all reals except for pi over 2 plus n pi. So that means n could be any integer. 1 pi, do you see that pi over 2 plus 1 pi would bring you back down to 3 pi over 2? And then plus 2 pi would bring us back up to pi over 2, plus 4 pi, or I'm sorry, plus 3 pi would bring us back down here. So basically it's pi over 2, and you add pi each time, and every time you add pi, you go halfway around the unit circle. So we have to exclude pi over 2 and 3 pi over 2 for the domain for tangent and secant. Now, likewise, the domain for cotangent and cosecant have the same problem. If you think about it, cotangent is x over y, and cosecant is 1 over y. So in this case, we are undefined at, do you see we're undefined when y is equal to 0? And do you see that y is equal to 0 at 0 degrees and at 180 degrees, or at 0 and pi? So we are undefined at pi and 2 pi, or 0 and pi and 2 pi. Basically anytime you hit the points 1, 0 and negative 1, 0, because the y values are 0 there. So here, the way we write our domain is going to be all reals not equal to n pi for any integer n. That is because we're saying any real number anywhere on the unit circle except for the multiples of pi. This would be 0 pi. This would be 1 pi. This would be 2 pi. Then 3 pi, 4 pi. Anytime you hit an integer of pi, that will land you at 1, 0 or negative 1, 0. And those are the 2 points where cotangent and cosecant would be undefined. Okay, and that's going to be the end of the first video.